Hello everybody! Today I can prepare for my equations of lines test by practicing. This might be the shortest test you ever take. It's a very short test. There's not a lot of topics. However, it's so important, so I wanted to really put the emphasis on the importance and make sure you practice so you can get these questions right now. You can raise your grade, and also these are all very, very important Regents questions, very common Regents questions. So we're really going to spend a little bit of extra time and really make sure we get these right. There's a lot of songs. It's like two different types of questions, but there's three songs. So let's start with those. We have our parallel song, we have our what minus what one, and we have our line dilation song. So let's go through each of those, and then we'll start going through the problems. So let's start with parallel.
Parallel has a same slope, perpendicular tone, perpendicular lines have negative reciprocal slopes, negative reciprocal slopes, flipped and negatives, negative reciprocal slopes.
So we need that song, and then we need to combine that with this next song for the first type of question.
Y minus y1 equals m. X minus x1 might have to distribute n I so late y minus y1 equals m. X minus x1 might have to distribute n I so late y.
All right, so let's save the third one for when we go over that. Let's start with number one. What is an equation of a line that is perpendicular? Perpendicular lines have negative reciprocal slopes. So I know if it's perpendicular, it must have the negative reciprocal slope of this line. So this line has a slope of 3 over 5. So my line, the negative reciprocal of that, flip it and negate it, is a negative 5/3. Now, it wants the equation of a line. That's y minus y1 equals m. X minus x1. I have my m, my x1 and y1 are the point that it passes through. So 3 and negative 6. Minus in a formula means change the sign. So I'm changing the sign of y1, I'm changing the sign of x1. So it becomes y plus 6 equals m x minus 3. Again, you're changing the sign of x1 and y1. That's what minus in a formula means. Might have to distribute, and I solely y. Look at the form that your answers are in. Your answers are not in point slope form. They're not in this form. So I'm going to have to distribute. Negative 5/3 times x is negative 5/3 x. Negative 5/3 times negative 3. You can use a calculator if you need to. It is positive 5. And again, there's absolutely nothing wrong with using a calculator. And I solely y. And again, you have a whole video, you have two videos of me going over this topic. You have equations of a line through a point and equations of a line through a point multiple choice. So you can refer back to those for more examples if you need to. The answer here is choice number 3. Number 2, I want you to try it on your own. So please pause this video, try number 2 on your own, and then unpause. All right, what is an equation of a line that passes through the point 6, 8 and is perpendicular? Now that you tried this on your own, Perpendicular lines have negative reciprocal slopes. Flip it and negate it. So, this line has a slope of 3 over 2. So my perpendicular line, the negative reciprocal of that, flip it and negate it, becomes negative 2 over 3. So I can already cross out choices 1 and 3 because they don't have a slope of negative 2 over 3. Now it wants the equation of a line. Y minus y1 equals m. X minus x1. X1, y1 is according to the point that it passes through, 6 and 8. Remember, this minus in a formula means change the sign. So positive 8 and positive 6 are going to become minus. Y minus 8 equals negative 2/3. X minus 6. Make sure you get the correct signs. Choice 2 is your answer. All right, let's move on to line dilations now. So again, our song is right here. Let's hear it first, and let's break down our song.
Line dilation, parallel, keep the slope. Center on the lines of X and Y on the line. Same B, off the line, different B. Origin, multiply, scale, factor, and B.
All right, so let's break this song down. Whenever you're doing line dilations, the image is always parallel, which means you're always keeping the slope. No matter what, with a line dilation, the slope is going to always be the same. From there, there's pretty much 2 different types of questions. You might see one that you're going to have to do that, or you might see one where you're going to have to do that. If it's centered at the origin, multiply, scale, factor, and b. If it's not origin, you're going to have to determine if the center is on the line by substituting x and y into the equation. If it is on the line, if it does equal out, then it has the same b, it's the same line. If it's not the same, if it doesn't equal out, if it's off the line, then I know the y-intercept has to be different. So let's take a look at number 5. Line dilation, parallel, keep the slope. I know that the slope has to be the same. So the slope of this line is 1/2. So the slope of my line must be 1/2. 3 and 4 are gone. Now there's 2 circumstances. There's origin and there's not origin. Origin. Flip back to the notes if you need to. Origin, multiply, scale, factor, and b. It's origin, so I'm multiplying the scale factor and the original b. 2 times negative 2 is negative 4. My slope is 1/2. My y-intercept is negative 4. Choice 1 is your answer. It's a conceptual lesson, this one. If you understand all the concepts, the math itself is simple. Number 6, line dilation, parallel, keep the slope. So, the slope here is 1/2, so my slope is 1/2. Can't be 3, can't be 4. Center on the line. Now, is it origin or is it not origin? It is not origin. So, I'm not multiplying the scale factor in b. I need to determine is the center on the line sub x and y. So I'm going to take this equation, and I'm going to substitute 0 for x and negative 2 for y, because that's the center of dilation. 1/2 times 0 is 0. 0 minus 2 is negative 2. Yes, it's on the line. On the line. Same B. Same B. Same slope, same B, same equation. Choice 2 is your answer. I believe that's all I want to go over with you here. I know it's a relatively short video here, but that's what you need to know. So, one more time, there's two types of questions that are going to be on here. There's equations of a line through a point. Y minus y1 equals m. X minus x1. That's your equation. That's your point slope formula, what you use whenever they want the equation of a line. And understand that you might have to distribute and isolate y if you want to put it into y equals mx plus b form, which we had to do in number 1 here. In number 2, they weren't in slope-intercept form. They weren't in y equals mx plus b form, so I didn't have to do that step. If it's open response, don't do that step. Other type of question, line dilations. Again, line dilations, parallel, keep the slope. For both numbers 5 and 6, no matter what the center was, in both cases, we kept the slope. No matter what, the slope stayed 1/2. From there, there's two circumstances. Origin, multiply scale factor and b. So since number 5 was centered at the origin, I multiplied the scale factor and the original y-intercept to get my new y-intercept. The other circumstance, centered on the line, sub x and y. That's what I did in number 6. It was not origin, so I'm not multiplying scale factor in b. I have to determine if the center is on the line, so I replaced x with 0 and y with negative 2. I did that right here. It equaled out, which means the center is on the line, which means that it has the same b, same equation, same slope, same y-intercept. Boom. Practice this. This should be a great test grade to raise your average. If you're not watching this video to raise your average, if you're watching this video for something else, these are two very important Regents questions that you need to be able to do. And that's all I got for you for today. So it's time to practice, practice, practice. Make sure you can do these two different types of questions, get a great test grade, and move on with your life. Have a great day and practice.